In this video, we'll continue our study of naming ionic compounds. However, when you look at some of these, you notice that there's more than just two elements involved. So this is going to be slightly more complicated. Anytime there's a group of elements like this, those are called polyatomic ions. Poly meaning many, and of course atomic ion, so that's many ions. So a polyatomic ion is two or more atoms bonded together that function as a single unit. So this is called hydroxide here. It's OH minus. This is called sulfate. It's SO4 minus 2. So notice that it's an ion because it has a charge of minus 2 and it's polyatomic. There's multiple atoms here. So polyatomic ions function as a single unit. They're going to stay together. Now on the handout that I've given you, on the back of your periodic table, there's a list of common polyatomic ions. So you'll have to reference these as we complete some of these problems. As you're looking at the list of polyatomic ions, you'll notice that most of the polyatomic ions are negative. Some are positive, but most are negatives. And most of the polyatomic ions have a suffix of ate or ite. And once again, not all of them, but many or most of them do. And fortunately for us, the same naming and formula writing rules will apply. However, the only difference would be instead of the name ending in "ide," it's going to end in what the actual suffix is, either ate or ite. But that's once again given to you on the back of your periodic table. So if you were going to write names for these formulas, you would name the cation first, or the metal first, or the thing that comes first. So name this first, potassium. And then on your periodic table, on the front, there's nothing like SO3. So you should recognize SO3 as a polyatomic ion, and that's found on the back of your periodic table, and it's called sulfite. So we have potassium sulfite, potassium sulfite. So here we have magnesium, and then you've probably never seen OH before on the periodic table, so check the back of your periodic table. It's probably a polyatomic ion. Turns out it is. It's called hydroxide. So this would be magnesium hydroxide. Now, if this is moving fast for you, I recommend that you pause this video and search the periodic table in addition to the list of polyatomic ions. So make sure you're familiar with these polyatomic ions before we proceed here. All right, you should recognize iron as a transition metal. And like we said, same naming rules apply. So because iron is a transition metal, we have to say what the charge is. And how do we know what the charge is? Well, just like before, we have to use the anion. So what is the name of this anion? You should be able to locate it on the back of your periodic table. It's called chromate, and it has a charge of -2. Chromate, once again, is CrO4. So this right here is chromate, and it has a charge of -2. But how many chromates do we have? It looks like we have 3 chromates. So if each chromate has a charge of -2 and we have 3 chromates, that means we have a total charge of -6. And we have to balance out -6 with +6. We have 2 irons, so what does the charge on each iron have to be to total +6? That's right, +3. So the name of this compound will be iron 3 chromate. Notice a couple things here. We're not saying iron 6, we're saying iron 3. So we're reporting what the charge is on just one iron. Also notice that this 3 does not tell us that there are 3 irons. What this 3 tells us is that iron has a charge of +3. All right, let's do this one here. So cobalt is a transition metal. So we need to say what the charge is. SO4 is on the back of your periodic table. It's a polyatomic ion. It's called sulfate, and it has a charge of -2. That means cobalt has to have a charge of +2. So the name of this compound is cobalt 2 sulfate. This would be an excellent time to pause the video and practice this one on your own. So once again, copper is a transition metal. You should recognize this from the back of your periodic table as phosphate. PO4 is phosphate, and phosphate has a charge of -3. But we have 2 phosphates, so that's a total negative charge of 6. That means we need a total positive charge of 6. So what does each copper have to be if we have 3 of them to total +6? Well, of course, it has to be +2. Because if we have 3 coppers, that's +2, +2, +2. That equals +6. So when we write the name of this, once again, we're reporting the charge on one of the coppers. So it's copper 2 phosphate.